Hello everyone, how is everyone doing? We will be looking at inequalities in this video. Now, of course, they make a fundamental part of algebra and also SAT. If you know how to solve linear equations, then inequalities will be simple for you. It's just about knowing how to solve simple equations. So first of all, let's demonstrate it in a graph. What do you call this? When you have a line and in the middle you have this zero. You call that a number line. We can see a lot of numbers on it and it's very simple. But what if x, which is our variable, is greater than -7? What happens there? Well, from this point, not taking into account the -7, I'll tell you why later on, to onwards, moving only to the right or towards infinity. What happens? If you have the variable and then you have greater than, it shows you that the direction you must follow is to the right, as we showed beforehand. Now, if the variable is followed by a lower than, the direction must be to the left. For example, from what I said, x will be equal to -7? It wouldn't. Why wouldn't it? It only says that it's greater than. It doesn't say it's greater or equal than -7. And if it has this stick below the greater than or the lower than, then it would take that value. What happens when we only have x is greater than -7? Well, it only takes into account the numbers from 6.99999 to infinity. 0 is also greater than -7, and so on. Having that being said, let's start with examples. For our first one, our parent statement is the following. 4x plus 9 is greater than 10. We must answer what value does x have. We plan to leave this x in this side of the inequality, and so we must pass the 9 to the other side to subtract, leaving us with 4x greater than 10 minus 9. Alright, 10 minus 9, it's 1. And so, if the 4 is multiplying, it passes to the other side to divide. X greater than 1 over 4. What does 1 over 4 mean? 0.25. And so x will be greater than that number. Represented on a graph, it would be like this on a number line, 0. So for example here it will be 0.25, the number we already had, and it will start from here, right? Not touching the 0.25, of course, since it is not equal to that number, it's just greater than. And if we had the greater than is to the right, it would go to that direction, meaning that x is present in every number after 0.25. For our next example, we will have the following parent statement. 6x minus 14 is lower than 2x plus 3. If I want to have the x's in this side and the constants in this one, well, the 2x will pass to the other side to subtract since it is adding, and the 14 would pass to the other side to add since it is subtracting, leaving the following. 6x minus 2x lower than 3 plus 14. 6x minus 2x is gonna be 4x lower than 3 plus 14 is 17. Since we want to have this x isolated in this side of the inequality, well, we pass the 4 to the other side to divide since it's multiplying. X will be lower than 17 over 4. We cannot simplify that. In the SAT, the answer will probably pop up like this, right? But sometimes it wouldn't. What do we have to do? Well, to divide in a traditional manner. What do I mean by that? Well, 17 divided by 4. By the way, that's not a square root. So, how many times is 4 in 17? It is 4 times. Since 4 times 4 is 16. Whilst a step further, 4 times 5 will be 20, and that surpasses 17. We subtract the 16, we have 1. And 1 over 4 did show before that it was 25, and so it is 4.25, our number, leaving us with a solution of x is lower than 4.25. Good. What happens with a graph or a number line? Alright, so we have here that this is 0. 4.25 over here in this side of the number line. Every number starting from what comes before the 4.25 will be present in that variable x, right? Since lower than meant the direction will be to the left. Now, what if we wanted to check? Let's start checking that that inequality had been found completely right. Let's start writing the parent statement back again. 6x minus 14 lower than 2x plus 3. Afterwards, What shall we do? Well, let's input a number to the variable we have, for example x. If we want to take this 2 and put it in the x's, this side must be lower than this other side. So let's prove it. 6 times 2 less 14 is therefore lower than 2 times 2 plus 3. Alright, 6 times 2 is 12 minus 14 equals negative 2. Now lower than 2 times 2, which means 4 plus 3 is 7. And so we can see that it is correct. Now what about a third and last example? We have as our parent statement the following: 4a plus 2 times a plus 4 is greater than or equal than 10a plus 20. So now that we have already covered greater than, lower than, now we're gonna go to greater or equal than. The first thing we have to do is to apply the distributive property, 2 times a and 2 times 4. So let's write it all again. 4a plus 2 times a is 2a plus 2 times 4 it's 8, greater or equal than 10a plus 20. Let's say that I want the a's here in this side of the inequality and the constants in the other side of the inequality. So we pass the 10a to the other side to subtract since it's adding, and the 8 to the other side to subtract since it is adding as well. 4a plus 2a minus 10a is greater or equal than 20 minus 8. 4 plus 2 is 6 minus 10 is negative 4a greater or equal than 20 minus 8, leaving us with 12. Now we want to pass the negative 4 to the other side to divide since it's multiplying. And so it would be a greater or equal than 12 over 4 with a negative sign to it. Are they multiples? They are. 4 times what number is 12? It is 3, right? And so a will be greater or equal than negative 3. Do not forget the sign, alright? The algebraic sign is really important, whether it's positive or negative, especially for these types of exercises that we are using the number lines. Since I mentioned the number line, now let's go to the next page and see how it would look like in a graph where we have the number 0. And over here, negative 3. As we saw before, it said greater or equal than. And so if it is equal, it would take this entire point, which is negative 3. And then if greater is to the right, then x will have all of this space. From negative 3 to infinity. Alright? This is infinity and this is negative infinity. That's what you have to take into account. Could be 0, it could be 10, it could be 100, and so on until you reach a vast amount of numbers which are categorized by infinity. Having that being said, thank you all for watching this video. I hope these exercises, I hope this video has helped you a lot. I'll see you next time. So